This is Mr. Martin. This is lesson 5.2 investigation for Geometry Advanced. We're going to talk about exterior angles of a polygon today. Talked about how to find the measure of the interior angles of a polygon. If you remember, the sum of the interior angles is 180 degrees times the number of triangles that we could divide it into, which was always 2 less, so n minus 2, than the number of sides. Remember, n is number of sides, I is interior angles, and then the big S is for the sum. So what we're going to do today is we're going to look at the exterior angles. So if you look at this picture, you can see the red angles here. I have one exterior angle at each vertex. Remember, to create an exterior angle, you simply extend one of the sides at each vertex. Only one of the sides, because when we talk about exterior angles, we only want to talk about a single one. So again, this pentagon here has 5 exterior angles. Okay? And they're not necessarily going to be congruent unless the polygon is regular or equiangular. It doesn't have to be regular, but it does have to be equiangular, but we'll talk about that in a little bit. Alright, so what we're going to look at is there an exterior angle sum? We're going to do a little inductive and a little deductive reasoning to figure this out. So here's what we're going to do. For each polygon, we're going to draw one exterior angle at each vertex and give the angles a number. So here's my triangle. So I'm going to extend each side, and it really doesn't matter how you do it as long as you get one exterior angle at each side. And then I'm going to give them all numbers. So I have 1, 2, 3, 4, and then 5 and 6. Okay? So we drew one exterior angle at each vertex, and we gave all the angles a number. Alright, so question number 1. How many linear pairs of an interior and an exterior angle are in the diagram? Well, here's one pair, 1 and 2. Here's another pair, 3 and 4. Here's another pair, 5 and 6. So we have 3 pair of linear pairs of an interior and exterior angle. So if we wanted to find the sum, what is the sum of all the interior and exterior angles? Well, I know that each linear pair is going to be 180, and I have 3 of them. So I have 3 times 180. So that's going to give me 540 degrees. Alright, and then we want to look at what is the sum of just the interior angles. So I want to look at 1 plus 3 plus 5. And again, we learned that to find the sum, we take 180 and we multiply it by the number of sides minus 2, and minus 2. In this case, we already know it's going to be 180, but a little bit of practice using our formula for the sum of the interior angles. And what we want to do in step 4 is subtract your answer from question 3, because this gives us all the angles 1 through 6, and this one gives us the angles 1, 3, and 5. So if I subtract those, I'll be left with 2 plus 4 plus 6. Alright, so I'll be left with angle 2 plus angle 4 plus angle 6, which is going to be the sum of the exterior angles. So what I get is 540 minus 180 equals, which is equal to 360 degrees. So I see for a triangle, the sum of the 3 exterior angles is going to be 360 degrees. Alright, so let's take a look at the next size polygon. Let's look at a quadrilateral. So again, what we want to do is we want to make an exterior angle at each vertex. So again, it doesn't really matter how you do it. We just need to extend one side at each vertex. And we want to number all of them. So I'm going to give this a 1, a 2, a 3, 4, 5, 6, and 7, 8. Alright, so how many linear pairs of an interior and an exterior angle are in the diagram? And if at this point you feel like you want to pause the video and work this out on your own, feel free. And then you can just kind of fast forward to the end of this little section to make sure you did it right. So we've got 1 and 2 is one pair, 3 and 4, 5 and 6, 7, 8. So we have 4 linear pairs. So notice that the linear pairs is going to match the number of sides. And what's the sum of all the interior and exterior angles? Well, I have 180 at 4 different vertices, so this is going to be 180 times 4, which is going to be 720 degrees. And then again, what's the sum of just the interior angle? So I want the sum of the interior angles. That's going to be 180 times n minus 2, so 4 sides minus 2, so that's going to be 360. And then subtract your answer from question 3 from section 4 to get the sum of just the exterior. Again, we're going to take all the angles that we added up in step 2, subtract out the inside ones, and we'll be left with the outside ones. So we'll get angle 2 plus angle 4 plus angle 6 plus angle 8. That's going to be 720, all the angles in step 2, minus 360, which is just the interior angles, and we end up again with 360 degrees. So we see that for a triangle and a quadrilateral, the sum of the exterior angles is going to be 360. So go ahead and pause the video and see what happens. We're just going to skip up to 7 sides. We just need a bunch of different examples here. And go ahead and do the same steps that we just did, but for this one. And then when you restart the video, you'll have what I've done as well, and you can compare our answers. So pause the video now and work out this 7-sided example. Alright, so here's this third example, and let's just go through each step. How many linear pairs? We have 7, so this is how I drew my exterior angles. Yours might be a little different, but we should still have 14 different angles. And we have 7 linear pairs. 1 and 2 is a linear pair, 3 and 4 is a linear pair, etc. So what's the sum of all the interior and exterior angles? Well, we have 7 linear pairs. Each linear pair is going to be 180. So that totals up to 1260 degrees. And then the sum of just the interior angles, so again, a little bit of review for us. It's going to be 180 degrees, so 180 times n minus 2. Remember our formula, S of I is equal to 180 times the number of sides minus 2, because this tells us the number of triangles that we could make, and that's going to be 900. So if we subtract the inside ones from all the angles, we'll end up with the outside ones, which are label those backwards. We want the even ones here. So we've got angle 2 plus angle 4 plus angle 6 plus angle 8 plus angle 10 plus angle 12 plus angle 14. Those are the exterior ones. So that's 1290 minus, or 1260 minus 900 is 360 degrees again. So from these 3 examples, what we might conclude using some inductive reasoning is that no matter what size the polygon is, so what did you notice about your answer to step 4 in every example? The sum was always 360 degrees. Okay, so that's kind of interesting. No matter what size the polygon is, if we take an exterior angle at each vertex and add it up, it's always going to be 360 degrees. So this leads us to our exterior angle sum conjecture. Alright, so the sum of the exterior angles of any polygon is always 360 degrees. And if we just want to write this in formula form, we would say S sub E for the sum of the exterior angles is 360. Okay, so we want to look at some equiangular polygon conjectures. And what do you know about equiangular polygons? Well, the nice thing about an equiangular polygon is that all angles are congruent. So if we know what all the angles add up to, because we have a formula for the sum of the interior angles, and we have a formula for the sum of the exterior angles, if we know that they're all the same, we can just divide the sum by how many there are, and that will tell us what each one is. So using the polygon sum conjecture, we're going to write a formula for the sum of the measure of each interior angle of an equiangular polygon. Okay, this is only good if it's equiangular. So the measure of each interior angle I in an equiangular polygon, well, we know that all of the angles are going to add up to 180 times n minus 2. And then if I divide that sum by how many there are, n, it will give us what each one is. Again, this is only good if it's an equiangular polygon. Alright, so there's that one. And then next, using the exterior angle sum conjecture. So let's go back up here. It says using the polygon sum conjecture, that was S sub I is equal to n minus 2 times 180. And then over here it says using the exterior angle sum conjecture, we know the exterior angle sum conjecture, S sub E, is always equal to 360, so that's kind of convenient. So then, if we know it's equiangular, the measure of each exterior angle E in an equiangular polygon is going to be what the sum of all of them divided by the number of sides, and that will give us each exterior angle if it's regular. So as you go through the examples, you can check at the end of the notes for the answers, but I do want to make one correction here in a picture. In this picture over here for number 3, there should be tick marks here for these 3 angles. Okay, and then over here in number 4, there's no D in the picture, so you could just cross that out. Okay, so go ahead and work on those 4 application problems, and if you have any questions, make sure you write those down as you go and ask me. And again, the answers to these are at the very bottom of this packet, and we'll see you in the next video.